with the start of section 5.3, and we're going to split this in two parts, we're going to transition away from proving into solving. Now, with solving, there is an equal sign, and you are trying to get variable equals. So you're going to have to move things from one side to the other. It's super important because we have these problems kind of mixed together. You got to read the directions. If it says prove or verify, you can only work one side, carry down the other side. If it says solve, then you are going to get like x equals or theta equals, alpha equals, y equals, whatever your variable is. So big difference. Main thing, read the directions. So you want x equals theta equals alpha equals. You're going to solve it just like you would any other equation. So manipulate it so that the variable is by itself, and then make sure that you get all of your answers. So make sure you use your trig identities. Make sure that you know how to add, subtract, multiply, divide things from one side to the other. That you know how to factor. That's huge. That one's going to come into play. One of the big warnings, though, huge warning, is you don't want to accidentally lose an answer. And that can easily happen. So here's the big one. Don't divide out variables at all. Now, if you want to rewrite them using an identity, that's fine. But if you have like sine x equals 3 sine x or half sine x, don't divide the sine x's out. That's bad. You're going to lose them. This is bad. So this is a no. Please, please, please do not attempt to cancel a variable. That's bad. Now, if you want to rewrite something, so let's say I want to divide cosine and turn it into tangent. I didn't lose it. I just rewrote it in another fashion. And make sure you give all solutions. So we're going to do some review as we go through this because there's some integrated 2 stuff that pops up and even integrated 3 stuff that pops up. So I'm going to give all solutions, all. Very similar to when we were graphing trig and you had to give me all of the asymptotes. You had to give me all of the relative extrema. So if you wanted to find all the x-intercepts of a sine graph, okay, same type of fashion. So what we're going to do here, I'm going to solve for tangent x is equal to 0. So I'm going to use what I know about the unit circle or use what you know about the tangent graph. I know that tangent x is equal to 0 when, well, let's see, tangent is sine over cosine. So if I think about this from the unit circle, this is when sine over cosine is equal to 0. Okay, well, that's really when sine is 0. Cosine could be +1 or -1. Okay, so I'm going to draw lots of pictures here. So I want sine to be 0. Well, sine is 0 at 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. And over here at pi. So I know that I am at 0 and I'm at pi. And then I'm at 2 pi, and then I'm at 3 pi, so on and so forth. So ... What I want to try to do, just like when I was doing trig graphs, is find a consistent distance between each of my answers, if I can. Because then I can wrap them all up into a nice, neat little package. I think I can do that here. If I'm at 0 and I go to pi, that is pi units away. If I am at pi and then I go to 2 pi, that is at pi units away. Notice that the distance on the top of the unit circle, if you want to think about it that way, and the bottom of the unit circle is the same. That means I can wrap all these guys up together. So x equals, pick one of the answers, 0. Plus or minus whatever that consistent distance is between them, n. This should look very familiar. We did a ton of this when we were graphing. So basically what this says is that tangent is equal to 0 when I am at 0 plus pi is pi, plus pi is 2 pi, plus pi is 3 pi. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, so on and so forth forever. 0 minus pi, negative 2 pi, negative 3 pi, negative 4 pi, so on and so forth. So instead of us having to attempt to write all of them out, we just give a nice, neat little package. Okay, let's take a look at the next guy here. So I am solving, well, the variable is x. X is stuck inside secant, so move the constant. So let's add the root 2 to the other side. So this is secant x is equal to root 2. So I'm just going to add it. Well, secant is the reciprocal of cosine. So cosine is 1 over root 2 if I do the reciprocal, but that looks familiar. 1 over root 2 is root 2 over 2. Okay, so let's think about where cosine is root 2 over 2 positive. Well, it's up there and it's down here. So this is one version is pi over 4. Remember, we have an infinite amount of coterminals. And then this one is down at 7 pi over 4. And I always check the distance, but like if you look at this, there's no way these are the same distance apart, like wrapped around. So if I'm at 1 pi over 4 and I'm going to go to 7 pi over 4, that is 6 pi over 4. That's far. Then I take a look at this distance from 7 pi over 4 back up to, well, it's going to be 9 pi over 4. This is 2 pi over 4. Those are not the same. You cannot wrap them all up together. So since 6 pi over 4 does not equal 2 pi over 4, each one of these guys is going to get their own answer. So let's do the pi over 4 one. So I have my angle, which was x. Well, x is equal to pi over 4. Plus or minus. I'm going to have to loop all the way around. So this 6 pi over 4, that didn't work. So let's get rid of that guy. Which means I'm now going to have to go all the way back around to get to that pi over 4 location. So that's going to be 2 pi n. So I couldn't wrap them together, which means I have to go a full loop. Well, you're going to have to do the exact same thing here with the red guy, because that didn't work. I couldn't get them together. So if I'm at 7 pi over 4, I'm going to have to loop all the way around to get back here. That's also a 2 pi distance. So this answer is going to be x is equal to 7 pi over 4 plus or minus, and that is also 2 pi n. Both of these are your answer. You have to give both of them, because each location, each one of those locations is going to give you that secant is equal to root 2. Okay, let's take a look at this next one here. Oh, okay. Well, I definitely don't want to divide by trig. That's bad. So I'm just going to put them on the same side together. So I'm going to subtract the root 3 sine x. So 2 sine x cosine x minus root 3 sine x equals 0. Okay, integrated 2, screaming right back at you. We're going to do zero product property because each one of these has a sine x in common. So I'm going to factor. So I'm going to get sine x. That's going to give me 2 cosine x minus root 3 equals 0. Find where your factors are separated and set each one of them equal to 0. So sine x equals 0 is sine x equals 0. Let's go ahead and solve this guy. 2 cosine x is equal to root 3. Divide by 2, cosine x is equal to root 3 over 2. Okay. All right, here we go. Sine x. Where does sine x equal 0? Well, sine x equals 0 at 0 and pi, and then 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and then negative pi, negative 2 pi, negative 3 pi, negative 4 pi, so on and so forth. I'm going to take this cosine is equal to root 3 over 2. I'm going to give its own graph, but then I'm going to transpose it on top of the other one to see if maybe I can wrap some stuff together. So let's put this guy in green. So where is cosine root 3 over 2? Well, those are at pi over 6s. So I'm going to be there at pi over 6, and I'm also going to be there at 11 pi over 6. Okay, so pi over 6, 11 pi over 6. Okay, if I take a look at this, before I even look at the other ones, look at how close those are together, and look at how far it is over there. There's no way those two can go together. Okay, let's see if we can move this guy over. See if I can paste it on top. Okay, maybe. Let's see. So I'm at pi over 6. Let's turn this into 6 pi over 6 so they match. So if I am at 0, nope, I don't think it's going to work. I got a little hopeful because that is 5 and that is 5 pi over 6. But that's not 5 pi over 6. That's not going to work. Okay, I don't think I can put the green and the black together. So let's move that guy off of here. So I think with the black one, I can do, that's got a consistent distance of pi. So this is x is equal to 0 plus or minus pi n. That takes care of those guys. And then let's go over here. These guys are going to have to be separate. So if they're separate, then that means I need a full loop to get them back. So for this one, this is going to be x is equal to pi over 6 plus or minus full loop 2 pi n. And then x is equal to 11 pi over 6 plus or minus full loop 2 pi n. I can't wrap them up. So the distance then is just a full loop to get back to where it was. So I think we have to have all three answers. 0 plus or minus pi n, pi over 6 plus or minus 2 pi n, 11 pi over 6 plus or minus 2 pi n. Really, writing out all three of these is still way less work than spending our entire life and then passing it down in our family for people to label them all out. Okay, let's see. I see, well, there's only one variable here, and it's the x. It's stuck inside the cosine squared. So let's go ahead and just add the 1 to the other side. So I'm going to get cosine squared x is equal to 1. Use what you know about getting rid of a squared. So square root both sides. So square root the left, square root the right. Be careful. When you square root, you better put plus minus. Don't forget. So this says cosine x is equal to plus or minus 1. Okay, so where does cosine equal negative 1? Well, cosine equals negative 1 over there. Or does cosine equal positive 1? Well, cosine equals positive 1 over there. I don't think there's any other answers here. That's all we got. So, and we already know this. This has a consistent distance. This is going to be 0 plus or minus pi n. Don't forget the plus or minus. You're going to forget half of the answers if you do. Okay, question number 5. Well, I've got x's in multiple places. They're both trapped inside versions of sine, though. So really, if we want to take a little miniature trip back to integrated 2, this is equivalent like 2u squared plus 1 is equal to 3u. You've got a u squared, a u, an equal sign, and a constant. Get everybody on the exact same side of the equal sign and factor. So that's what we're going to do. I'm going to move my 3 sine x over. So this is going to give me 2 sine squared x minus 3 sine x plus 1 is equal to 0. I'm going to do my boxes and diamonds and factor. This is going to give me 2 sine x minus 1, and then sine x minus 1 equals 0. Use 0 product property. 2 sine x minus 1 equals 0. And then sine x minus 1 equals 0. And then solve. So this is 2 sine x equals 1. Sine x is equal to a half. Okay. I know where sine equals a half. Sine equals a half. Remember, this is a y value. So I don't want my triangles to be ridiculously tall, but I do need them to be positive. So there we go. I think this is going to be at pi over 6. And then this one is going to be at 5 pi over 6. All right, let's go do the other one. So this says that sine x is equal to 1. So I'll go ahead and color code this one. Sine is equal to 1 up here at pi over 2. And I'm going to do the same thing. I'm going to copy this over, and I'm going to try to transpose it on top of this one and see if there's some sort of a consistent distance. And I don't think there is. Like, this distance is the same as this distance, which is great. But finishing the loop, that's way too big. So I don't think that wrapping these together is going to work. So let's take the green guy off of there, which means I think everybody needs their own answer. So for the first one, I have x is equal to pi over 6, plus or minus, no wrapping, got to loop all the way. This one, x is equal to 5 pi over 6, can't loop it with anything else. So you have to go all the way around to get back to it. X is equal to 5 pi over 6 plus or minus 2 pi n. And then this guy, we're going to get x is equal to, so pi over 2 plus or minus, had to do a full loop, 2 pi n. So we do have to write out all three of these to make sure that we have all of the answers that actually satisfy the equation. Okay. Let's see, 4 cosine squared x minus 3 equals 0. We had something very similar to this like 2 questions ago, right there. So I only have one variable, move my numbers to the other side, and then square root. Don't forget your plus minus. So I'm going to add my 3. So this is 4 cosine squared x is equal to 3. I'm going to divide by 4. And then I'm going to square root, plus minus. Don't forget the plus minus. You'll lose half of your answers. Cosine x equals plus or minus. You can square root a fraction, so you can square root the top and the bottom independent of each other. So square root of 3/4 is the square root of 3 over the square root of 4. Well, square root of 3 is just square root of 3. Square root of 4 is 2, though. And now this looks familiar. So we want to know where cosine is equal to positive root 3 over 2. So that's there and there. And the negative root 3 over 2 is there and there. And honestly, I think we can wrap some of this together. So if I am at pi over 6, and then this is going to be 5 pi over 6. This is 7 pi over 6, and this is 11 pi over 6. I can't wrap all of them together. So like, look at how close those two are and how far apart those are. This is not going to work, not all 4 of them. But if I start at pi over 6 and I go to 7 pi over 6, that distance is plus pi. Or plus or minus pi. So I think we can put the pi over 6 and the 7 pi over 6 together. So let's do x is equal to pi over 6 plus or minus pi n. And that takes care of pi over 6 and 7 pi over 6. I think we can do the same thing with the 5 pi over 6 and the 11 pi over 6, because that distance on both sides is also plus or minus pi n. So the red distance takes care of both pi over 6 and 7 pi over 6. And now we can do the green. So 5 pi over 6 plus or minus pi n. So even if you can't wrap all of them together, you might be able to wrap some of them together. Oh, and that brings us to the end.